Most AI applications fail in production because developers treat them like traditional software. They're not. I'm about to show you the exact moment an AI agent decides whether to search your internal knowledge base, browse the web, or write and execute Python code, all automatically based on your question. We'll build a React agent that can handle Newton's laws from memory, fetch lens equations from DuckDuckGo, and calculate the 15th Fibonacci number by writing its own code. Watch this reasoning chain in action. Let's start with the lightweight setup and see how it makes intelligent decisions. Here's the code. If you're still using old Faang prep guides, you're already losing ground. The rules have changed, and this free AI playbook shows you what's really being tested in modern Faang interviews: insider strategies, hidden evaluation matrix, a 90-day mastery plan, the exact playbook successful candidates are using right now. Everyone's grabbing it, don't be the one left behind. Link in description. So now let's jump into the actual demo. So this is the code walkthrough of the solution that we've designed and architected. Some of the challenges when we deploy LLMs are very different from traditional ML. They're non-deterministic, meaning the same input can give different outputs. They're context sensitive. Small changes in prompt can completely alter the answer, and they're harder to evaluate. Accuracy isn't just numbers, it's reasoning, reliability, safety. On top of that, we need to manage hallucinations, latency, and costs. That's why we need LLM ops, extending ML ops with evaluation, monitoring, and workflows specialized for LLMs. So I'm going to start off by installing the basic packages that we are going to use, and that is dspy. That is a Python package from Stanford that helps us do LLM ops and orchestration of the entire stack. We're going to install the OpenAI's SDK and DuckDuckGo search, as that's our search tool. The key point: this setup is very lightweight. You might observe that dspy abstracts away boilerplate and gives us a high-level interface for building agents. Instead of writing prompts and parsing outputs manually, we just declare tools and logic. The next step is to configure the language model. I'm configuring the language model. I'm using OpenAI's ChatGPT 4o Mini, which will act as a reasoning engine. Why we've chosen this? We've tried to test out a relatively small rather than a very flagship offering from a player like OpenAI to assess the performance that we achieve from it. Introduction: this step would be tied to secret management and configuration management, part of the LLM ops pipeline. Think of it as choosing your models, setting the guardrails, and plugging it into your infra. The key thing to notice over here is that we've imported our every third party external API needs a security token to access it, right? So the API key defined over here, for security reasons, we've defined it into the Google Colab notebook secret management tab that you'll find on the left hand side of your screen on this toolbar. So once you configure your environment secrets over here, like you can use Google Colab's library and import the parameter called user data, and that would help you to kind of fetch any environmental secrets that you stored in your notebook. And then using that, we have initialized the language model properly. So we get a confirmation that the language model is configured. This confirmation is post hitting the LLM and checking whether the key works or not. Now I'm defining a toy knowledge base with a set of statements, that is Newton's laws. How does that help? Like, for example, in a real company, this could be your FAQs, internal policies, compliance rules, or financial docs. The idea is to show how you can ground the model in curated data instead of merely relying only on its training. This is the first building block of retrieval augmented generation. So as you can see, the knowledge base is created with 6 documents. 6 documents being the 6 statements. This is a basic building block to start with. This can be scaled to like millions of documents that you have, which you need to use for a RAG lookup. The next step is to define the tools that extend the LLM's abilities. I have 3 over here. The first one being SyllabusSearch to fetch from our internal knowledge base, then WebSearch to fetch fresh information that the knowledge base doesn't cover, and the last one being the CodeExecutor. So the model can write and run Python code when it needs precise calculations. This makes the agent more reliable because raw LLMs can hallucinate or miscalculate. But if they can call tools, they can ground their answers in real data and computations. For embedding, we are using OpenAI's text embedding 3 small model for embedding the knowledge base that we have. So as we see, the tools are ready. The next step is to kind of build a React agent. Now let's come to the decision of using dspy. So why are we using it? So when people build with LLMs directly, they usually hard code prompts, right? They go out and write messy glue code and debug things in a very ad hoc way. That's brittle. It doesn't scale. dspy solves that by giving us a standard, structured, declarative way to define LLM systems. Inputs, outputs, tools all defined clearly. Reproducibility, no scattered prompts, it's modular code. There are reasoning traces and decisions that are logged. We can swap models, tools, or retrievers without breaking the entire pipeline. That's why dspy is a great fit for LLM ops. It basically takes care of all the best practices that you need to do and makes your solution scalable. And it is open source. So it is a great community that is supporting the entire stack. Now, what is React? This is another key concept. It stands for reason plus act. Instead of just predicting answers, the model goes through a loop. First, it reasons step by step, writing down its thoughts. Then it acts, calling a tool like search or code. Then it comes back to reason again until it reaches a conclusion. Why is this important? Because it makes the process transparent and controllable. We can inspect the reasoning, stop it if it goes wrong, and log everything for monitoring. That's exactly what LLM Ops cares about: safety, observability, and accountability. Now let's run the agent. So the agent is now built with a simple dspy command. So I've built the agent. So this ensures that the agent doesn't just hallucinate answers. It reasons, decides when to use tools, and executes them. And then, if required, reasons them again. So this is typically how LLM powered workflows are structured in production. Now let's come down to scenarios. So the first scenario is internal retrieval, that is a RAG. Let's ask, what does Newton's third law state? Watch carefully while we ask the to kind of look up into the document we've given it. So in the response, the agent first thinks, it looks at the knowledge base, reasons about the relevance, and then retrieves the right entry. The final answer is clean. For every action, there is an equal and opposite reaction. This shows how we can ground answers in internal data. So this is a response that we've got, and this is a reasoning that it underwent. And then we have a confirmation message that okay, the entire chain of thought is completed. Let's go to scenario 2, where we use WebSearch for seeking the answer. So we are going in with a question that what are the lens equations? So if you just briefly, while the execution is running, if you can just see over here, we have just given basic text-based theories of the Newton's laws in our memory corpus. But we haven't given the exact answer to this. What are lens equations? We haven't given any mathematical equation to it. So what happens now? Since it's not in the knowledge base, you may notice over here inside the trace that it checks the syllabus and it finds nothing. Then decides to call DuckDuckGo, that is a browser agent. You can literally see the chain: reason, act, fetch, reason again, final answer. This is what makes the workflow auditable and safe. So you have all the arguments from each of the tool call, its observation, then its thought, then again if another tool is used, and finally it comes up with a trace of the entire chain of thought and the external tool call, and then it drafts it into a response to that the user can consume. Okay, so it comes up with the formula that we wanted as lens equations. So in production, this allows us to trace why the system answered the way it did. And this gets really critical when you want your LLM or your app that is a wrapper over your LLM really compliant. And that is what separates from a vanilla wrapper to a matured AI based solution which serves your purpose. Let's come to the third and final scenario, that is code execution. Let's ask, what is the 15th Fibonacci number? Okay, so this is my question. So this is clearly not, if you just go back again, it is not in the knowledge base. I'm not sure if it would go out and check in the web about a specific query like this. My question is about what is the 15th Fibonacci number. It can either be what is the nth Fibonacci number, right? So if you just look at this tool chain, it says that like the agent reasons, like this is a math problem. It is not a like knowledge based lookup or a web search, right? It has clearly understood that. Then it decides to write Python code. It executes it, and ultimately it gets the result and then returns the final answer. So what did the user actually want? The user only wanted the answer to their specific question, but the model had to take an approach where it could not hit the knowledge base. For the RAG approach, it could not plainly hit the web search API because it might not get the right answer. It very rightly assessed that this problem statement requires some calculation. And for it, we had already given it a Python interpreter through a CodeExecutor tool. So you see over here the response that this is the reasoning part. The 15th Fibonacci number can be determined by either calculating through a function or looking up it in a sequence. So it has clearly taken that approach to calculate it and then give an answer. So this is this was a short demo we saw in this is a miniature MLOps pipeline in action. We configured a model and connected it to tools. Use React to structure reasoning, grounded it in internal and external knowledge, and even executed code. The key takeaway is MOps isn't about just serving a model. It's about building structured, monitored, safe workflows around LLMs. We have taken an example by using dspy. dspy and React give us a way to kind of operationalize these principles. The principles are reproducibility, observability, and modularity. This is how we make production apps really trustworthy and reliable, and build a ecosystem around it, and put it inside a workflow that is already in place and in production. So yeah, that's a wrap up. If you like this video, you will love what I have to say next. The 14-week Agentic AI program at Interview Kickstart helps engineers build real, career-ready skills. You'll work on 2 live projects with Faang instructors and leave with portfolio work that actually makes a difference in hiring. Over 20,000 tech professionals have already trained with Interview Kickstart, with many moving into roles paying $300,000 plus. Want to learn more? Join the free upcoming webinar. Ask questions, meet the instructors, and see if it's a fit. Not ready yet? No problem. Start with the AI agent building videos here on the YouTube channel. We recommend this one. Either way, the key is to just get started.